Dear ladies and gentlemen, welcome to our ApplanixPPK webinar today with the title Unveiling the Strength of PPK Processing by Leveraging RTX. Thank you for joining our webinar. We really appreciate your interest, and I'm happy to host this session today. My name is Nico Jäger, and I'm the product manager of PPK and its variants, which is our post-processing software for GNSS inertial data and GNSS-only data. I'm joined today by Henny, who is our development manager for our PPK Cloud products. Henny will demo the ApplanixPPK web application and help today to answer questions during the Q&A session. In addition, we have Santia here from our marketing team to help us in case of any technical issues with this webinar. Before we start, I wanted to raise also your attention to our previous recorded webinars, which you can watch in our webinar center at applanix.com/webinar.htm anytime you want. Okay, so some logistics for this webinar before we go more into the details. The presentation will last approximately 30 minutes, followed by a live demo, approximately also 10 minutes, and then we have another 10 minutes for the Q&A session. The webinar will be recorded and shared with you, and all attendees are muted. However, if you guys have any questions during the session, please use the Q&A box at the bottom. And we'll try to answer the questions during the presentation, during the Q&A session, or if you're running out of time or the question is too complex, we're getting back to you offline via an email. Okay, what's the agenda today? First of all, I would like to clarify what ApplanixPPK is and how it works. We speak about the input files that you need for this web application and what the deliveries are. We speak about processing modes that are supported and PPRTX. That's the most exciting processing mode that I would like to emphasize here today. The supported plans for the web application, some additional features, and then we get to a summary and the demo session handled by Henny, plus the Q&A session at the end. Okay, so what is ApplanixPPK and how does it work? So ApplanixPPK is a very easy to use web application that does use a cloud service infrastructure at the back end, and it allows you to post-process kinematic GNSS differential position data from UAV data and or drone data. So this is post-processing is really happening in the cloud backend. So you can consider this as a PPK as a service module where the users can sign up on a monthly subscription, and they can also purchase add-on minutes in case of the monthly subscription does not satisfy your flight minutes that you can process through. I will explain that a little later when we get to the plans itself. This really follows a pay-per-use model where basically you pay per flight minute of data. The whole thing is optimized for camera UAV payloads, and ApplanixPPK is GNSS hardware agnostic. It really runs with any kinematic RunX file. The minimum requirement for the kinematic RunX file is you have at least L1 and L2 GPS observables. But of course, it's better you have also other satellite navigation raw observables from Galileo, GLONASS, Baidu, etc. So how does it work? You guys probably know that PPK stands for post-processed kinematic, and it is an alternative approach to the famous RTK mode. RTK stands for real-time kinematic, where the correction data are coming into the receiver in real time. PPK mode, you merge basically your rover GNSS data with base GNSS data or with the famous Trimble RTX corrections to geotag your images, to directly georeference your images in terms of position information. And when you run things in a PPK mode, you obviously mitigate GNSS errors through the forward and backward processing and smoothing, which is inherent in any post-processing engine. So based on that, you already realize there are some benefits of PPK versus RTK. For instance, if you operate with RTK, obviously you need to have a real-time link. PPK does not rely on any kind of a real-time link via a radio or internet to obtain correction data. We'll do the job later on. That means also when you operate in RTK, you may have correction disruptions, and hence the whole thing is susceptible to potential link interruptions causing sudden performance degradations. That will obviously never happen if you post-process your data in PPK mode. And of course, when you run things in PPK, you don't need any additional hardware in air, such as a radio transmitter or internet connection. So the entire web app is basically very simple. We designed it very simple. You can easily drag and drop your input files into the web app. At the end, you submit the project, and after the data have been processed in the cloud engine, you're going to get your results as a zip file. So Henny will demo that in a couple of minutes. You'll see how easy that is. So what are our input and deliveries? The mandatory input file is obviously the kinematic RANX file or the rover RANX file from the drone. That should have, as I said before, a minimum of GPS L1 and L2 observations, but ideally also other GNSS satellite observations. The more, the better the reliability and the performance, obviously. Optional, you can provide your own base file if you have the base file. Alternatively, the engine will automatically try to find a base file and process data, for instance. You can supply your photo ID file. A photo ID file is basically a file that contains the timestamps of the image trigger moments and an image number. So that's important for the app to get. But if you don't have that photo ID file, we have a photo ID editor tool that allows you to create that photo ID file based on an event file. And an event file, again, is just having increments of events and a timestamp of when the image was taken. So an exact timestamp is obviously needed. Plus, you need to have your images available. And when you link the images with the event file information, then you can create that kind of photo ID file. The target is obviously that you have the photo number, and at the end, for each photo number or photo ID, you will have position information, so north, east, down, or X, Y, Z. So this here demonstrates the photo ID auto generation that is embedded in this web application. So what you need to do is upload your event file. Again, an event file has just incrementing event numbers and an associated event time, which is typically GPS time. So again, the trigger timestamp of the images. So these are the two columns that we would need. Then you would point to the images that are part of that project. And at the end, you will have the photo ID file generated. Very important is that the active events are matching the active images. So you can see on the right side in that red frame, we have 204 events matching 204 images. And that's the whole purpose of it. At the end, you just click generate photo ID file. It will do that in the backend to be able to deliver you the north, east, down, so the position information per image. So what are the ApplanixPPK deliveries? the entire delivery is packed in a zip file that's going to be sent to you in an email, or you can also download directly from the app once you're registered under your profile. So these are the two routes. What we supply right now is an Applanix standard ASCII file in the UTM system at the exposure times. So at the event times, again, coming from the photo ID file I explained before. So you will get photo number and northeast down information, so the position information. In an ASCII file, you also get an UAS master project file, which is our photogrammetric software that Trimble offers as a portfolio. It's called UAS master, specifically designed for the UAV and drone industry. Plus, along with those files, we provide you the standard SPED file, which is our famous smooth best estimate of trajectory at 1 Hertz, and another ASCII file at 1 Hertz in the UTM system, including geographic coordinates. And there is another file that we supply that's called the report file. It's a PDF with many plots and information about the results of your post-processing steps. So that could be very helpful for quality control and quality assurance of the data. So let's get to the processing modes. As I said before, the most exciting processing mode is PPRTX. It stands for post-processed RTX. I'll have some more slides in a couple of minutes for that. It basically is a worldwide cloud correction service from Trimble, where you guys don't need to provide any base stations. And those corrections are used kind of automatically, and you'll get a centimeter level solution using all of the satellite navigation system data that you bring with the kinematic graphics file. In addition to this very easy PPRTX mode, we have also the traditional processing modes. This is the single base processing mode, where we can also automatically download available base stations from a database that we maintain. We speak about more than 10,000 base stations that we support. And a little hint here, we have a Trimble GNSS augmentation planner app where you can see the base stations that are surrounding your mission area. It's a free of charge app. I have another slide at the end of this presentation here and explain a little bit around it. In addition to the single base auto download feature, again, where it takes a base station that is available free of charge from somewhere, we'll download it. You obviously can also upload your own base station. As a user, if you have your own base station, that's a very traditional approach. Base stations should typically be within 20-kilometer range to minimize the GNSS error budget. And the good thing here is, even if you have no idea about your coordinates of the base station, we can also leverage the RTX technology here and survey in your coordinates to proceed with the standard processing. In case the base station that you have uncertainty about the coordinates. And the last option is the smart base option that does use multiple stations with large baselines, for instance. Those base stations are also downloaded automatically. Multiple base stations are typically surrounding your mission area. And we're driving a virtual reference concept at the back end. And the nice idea here is as well, if there's not sufficient base stations available that can be used in that multi-base station concept, we have a fallback mechanism that it brings it always back to at least a single base solution, always given the fact that a base station is somehow available from the database. Okay, so let's speak about the Trimble RTX concept. Trimble has a network of GNSS tracking stations worldwide. We speak about 100 and plus, collecting the data day and night. And all that data are processed in a control center. And via a very smart algorithm, it creates a set of correction data for the rover. It corrects for the standard GNSS error budget, such as for satellite orbits, clock errors, atmospheric errors, which are typically ionospheric and tropospheric errors. And it makes those corrections available in real time as well as in post-processing mode. Well, for our PPK processing, the interesting part is obviously the post-processing mode. So we call this ApplanixPPK post-process Trimble CenterPoint RTX, in short, PPRTX. So as I said, it was introduced as a real-time CenterPoint RTX service at the beginning, and that goes back to 2011. And it relies on those precise orbit clock information atmospheric delay models for GNSS satellites. And we speak about all satellite navigation systems here: GPS, Galileo, Baidu, GLONASS, QZSS. And PPRTX itself is a cloud-based global GNSS correction service now utilizing the Trimble RTX technology to provide centimeter level post-process positioning. And again, I want to emphasize in that case, users don't need to think about any base stations, right? So it just takes the corrections from the server, and within minutes after your data acquisition, you can make use of it and post-process your data. So that makes it a very powerful alternative processing mode to the traditional single base and smart base GNSS trajectory generation. So when we speak about PPRTX, the Trimble CenterPoint RTX services are split into two regions. We have the so-called FAST region, which is in Central Europe and North America, and we have a global region, which is the rest of the world. The global region corrections are based on a global ionospheric model, while the FAST region uses a denser network of reference stations to compute a regional ionospheric model for atmospheric corrections. Anyway, PPRTX in general is really covered globally. Just the fact that you have a quicker convergence time in the FAST region, and we have a converged solution typically in the FAST region of 1 to 2 minutes, or after 1 to 2 minutes for all satellite constellations. But getting almost the same convergence time in the global region if the additional and latest Baidu 3 signals are available from the kinematic rover. Otherwise, it may take a little long. However, I want to emphasize that the convergence time drives the minimum length of the rover data. So typically, you're good with 10 minutes of data in the FAST region, and you would also be good with 10 minutes of data in the global region if the Baidu 3 satellite generation is on board. Otherwise, in the global region, you probably need to have 20 minutes of data to have a perfect converged solution. So what's the performance that we can expect? Horizontally, we typically state below 3 centimeter accuracy. So horizontally means north and east, or X and Y. And in the vertical direction, we have an RMS value of below 6 centimeter. That's what we can achieve by using PPRTX processing in the global as well as in the FAST region. So here's an example where we compared the PPRTX trajectory solution versus the single base solution, given that the single base solution typically provides a very good solution when the base station is close by. So this is from an airborne flight here, where the base is below 10 kilometers range. And we compared the northeast down axis here. On the left side, you can see the graph over the GPS time. And if you take all of those residuals and you compare both, we obtain an RMS value horizontally of 1 centimeter, and in the down position, so in the Z position, about 2 centimeter. That even outperforms of what I said before, but that's not a big surprise. We're kind of conservative about the RMS values that we typically state. And here's another example, same procedure, PPRTX process versus single base. We have an RMS horizontally about 1 centimeter, and vertically it's 1.6, so you can see 2 centimeter. The latest PPRTX processing engine that we use, we call that also GNSS Plus NAV PPRTX2 generation. That is very beneficial in the global region, as long as you have the additional Baidu 3 signals available. And what we did here is we compared PPRTX standard processing versus the latest PPRTX processing, which we call PPRTX2. We compared that over 66 UAV data sets, and we always compared to a single base reference where the base station was very nearby, so below 10-kilometer range. And as you can see, with the standard processing in the global region, we obtained something about 2 to 4 centimeter horizontally and 9 centimeter vertically, while with the latest method, we obtained 1 centimeter RMS horizontally and about 5 to 6 centimeter vertically. So that means we have an approximate improvement of 100% with the latest PPRTX processing mode, which is embedded in the ApplanixPPK web application. Okay, so that brings me to the benefits of ApplanixPPK in combination with PPRTX. So first of all, whenever we use PPRTX, as I said, we don't need a base station. And that relieves you of pitching your base station yourself or sourcing a base station from commercial providers or even stations that are available free of charge, but you need to look for FTP sites and download that. All of this, headache and extra steps, they're just not available and not needed anymore when you use PPRTX. This service is covered worldwide. There is no limitation for that service. The correction data are available within a very short time after your data acquisition. Obviously via internet, that's what you need to have. But because you use ApplanixPPK, you don't worry about it. It's in a cloud environment anyways. Using ApplanixPPK has also a big benefit over having piece of software installed on your machine locally, because this is just a subscription-based product, and you save a lot of cost to purchase a piece of software and install it and pay maintenance for it. This just runs on a subscription, so it just reduces upfront investment for software purchase. You always use basically the latest software with the cloud subscription, so the vendor is obviously responsible of running the latest software in the cloud environment, whereas when you run locally software like desktop software, you purchase at some point, and you have to buy maintenance and update. And we know how it is. Many people have lapsed maintenance, and then they're not running the latest software. That's all not the case in the cloud environment. You're always running the latest and the greatest. There's no baseline restrictions with PPRTX, as I explained before. No worries about that anymore. It improves the efficiency and productivity. And we've seen very often that by using that method to process your data and run PPK in general, you reduce the need of many ground control points. So you would need less ground control points or even no ground control points, really depending on the application that you run. And you will obtain results in a few clicks, easy and simple. Okay, so what are the supported plans here? As I said before, this is a subscription-based product. We have 3 different plans out there. First is a trial plan. That means you have 35 flight minutes for free, where you can use the ApplanixPPK app. The trajectory is obviously being processed at no charge. Just to clarify, flight minutes are the dynamic or kinematic part of the logged GNSS rover data. Any static data are ignored. Only the dynamic data are accounted for. So based on time and velocity thresholds, ApplanixPPK detects the dynamic part automatically and can sum up the proper flight minutes. So that brings me to the base plan. The base plan is a monthly subscription. It costs about $37 US, and it includes 50 flight minutes. Again, flight minutes are the dynamic or kinematic part of the log GNSS rover data. By the way, if you have to reprocess something because you detected a failure or you uploaded a wrong base station, for instance, whatever, you can always reprocess your data, and we are not going to deduct the minutes. So reprocessing is free of charge. And the base plan does include all of those different processing modes that I explained before. PPRTX, Single Base, and Smart Base are part of it. Should you operate more drones and you require more flight minutes on a monthly basis, we have these so-called add-on plans. Those are a quantity of 50 flight minute sets that you can purchase. So multiple tiers are possible to purchase, and we discount based on the number of tiers that the user does purchase. Those flight minutes are available over a 12-month period. So if you purchase multiple sets of those flight minutes, you can just use them and spread out over 1 year. They are still valid, and you can process your data. Okay, that brings me to, let's say, some answers for FAQs. I'm not going to go through the questions, rather to some answers on that part, which is a reiteration of what I said before, kind of. So the base plan renews on the monthly basis unless it is canceled prior to the renewal. Our base plan supports 50 flight minutes on a monthly basis. Should that not be enough, you can always purchase extra flight minutes as an add-on package, and they are discounted by tiers. So discounted by the number of packages that you purchase. Add-on flight minutes expire only after 12 months or upon the cancellation of the base plan. And reprocess projects will not cause any flight minutes deduction from your plan contingent. So some additional features. I think I mentioned before that we can also use the PPRTX engine for static survey-in base stations. So what happens if you have a base file but you don't have the coordinates? That's all embedded in this ApplanixPPK engine. You can obtain very precise coordinates for your base station. You just have to click on RTX base position when you upload your base file, and it will automatically determine the coordinates, and it will also ensure to remove any datum shift concerns. Typically, surveyors are, they're very often concerned about datum shift effects, and that's because if the base station is provided and you have some coordinates and you don't know in what frame the coordinates are, is it the ITRF 00, ITRF 2020, is it NAT 83, or is it the ETRS 89? If you're unsure about that one, you can use that RTX survey-in functionality. So it's nothing else than basically a static PPRTX processing mode. And the same thing, it's available within minutes after your data acquisition. The supported files are the Trimble native file format, which is T02, and Rhinex version 2 and Rhinex version 3. And yeah, that gets me to the TGAP. Another thing that I mentioned before, TGAP stands for Trimble GNSS Augmentation Planner. This is an easy-to-use web app, which is free of charge, and allows you to visualize the Trimble correction services worldwide. So we have a database of more than 13,000 reference stations from 40 networks in 160 plus countries. And the web app is as easy as you go in and you draw your area of interest, and it will make even a suggestion of how to process your data. It will also visualize the correction data available. You can also load your kinematic Rhinex file and it will again suggest a certain processing mode and visualize the correction data that are available. So I encourage you to go there, test it out, and it's 100% connected to what we have embedded in the ApplanixPPK web application. So GNSS arcplanner.trimble.com is the tool that you can use free of charge anytime. And that brings me to almost the last page here. So you realized that ApplanixPPK is a nice tool if you deal with 1, 2, or 3 drones. But what about you have really a massive fleet of data, a high volume of data that you want to process, or you are even a system integrator, or you have your own cloud application already and you process many, many data? We can supply you a Prospect Cloud API to have a tighter integration with our cloud service. We will give you a staging and a production environment. The staging environment, obviously, to allow the integration and testing of things. And then when you go into the production environment, then it starts, obviously, the commercial part of it. The Prospect Cloud service and engine is monitored. It's very redundant. So we have that standard 365, 724 monitoring service of this cloud environment. And by the way, that applies also to ApplanixPPK, of course. And in terms of the cost, we still pursue the same idea, pay per use concept or subscription concept. So when you guys think about onboarding, then we'll go deeper into this thing. But just realize that, you know, for high volume data processing, this is a very good alternative to ApplanixPPK. Okay, that brings me to the summary and the demo and Q&A session. So as a easy summary, ApplanixPPK is a web app to optimize UAV payload, GNSS positions, leveraging Trimble's post-process CenterPoint RTX technology. It's very simple to use and it makes mapping just perfect. Okay, that brings us to the live demo. So I will hand over to Henny and stop sharing my screen here. And Henny will guide you through the web app and demonstrate how easy that is.
All right, great.
Okay.
All right, thank you, Nico. I'm Henny Mora, the development manager for the Applanix cloud projects. And we're just going to walk through a quick demo on how this all works. It's like Nico said, it's pretty straightforward, but we wanted to, walk through the steps. And as soon as we're done here, we're going to open up the Q&A. I already see some questions coming in, so we're excited to answer those. Just about a 5-minute demo, and then we'll hop right into the questions. So to try this out for free or to log into your existing account, if you already have one, you can just go to ApplanixPPK.com, sign up for your free trial. Or if you already have an existing plan or an existing account, you can log in right here. So once you're in, it's kind of straightforward. So you give it a project name. I'm just going to give it, test project 5, for example. First thing you want to do is import your Rhinox rover data. So it has to be in Rhinox format. You can either browse or you can drag and drop. So I'm just going to drag and drop my Rhinox file. And by default, it defaults to PPRTX. But like Nico mentioned, we do have other processing modes. We have the smart base, the single base, where you can specify your base station or use RTX correction to correct your coordinates. Or you can use single base automatic download, which grabs the nearest base station if it's available. But by default, we highly recommend you go with the PPRTX mode. And the last question it needs is, it's actually optional, but it's what Nico mentioned, is a photo ID. So it's basically a file that correlates your events from your drone with the actual image names or IDs. So I'm going to walk through how a photo ID is created. So if you have one in that specific format, you can upload it directly. But in most cases, you're probably going to create it through the platform. And it's about 3 or 4 steps. So we're going to walk through it very quickly. I'm going to say create a photo ID. So the first question is, what is your event file? So basically need to know, times and some kind of event ID and times of the photos taken. So if you have an MRK file, it's a common file format there from certain drones, you can use the MRK directly, but really it's compatible with anything. Any file, any kind of ASCII file you drag in here, you can go and align the columns in step number 2. So first one is you upload your event file. Second one is you basically tell it which column represents the event number and which column represents the event time. And some formats may have extra information that's not really relevant, so you can completely ignore them. All you need to do is decide which column represents the event number, which column represents the event time, and then you can proceed to the next step. And for MRKs, it detects it automatically at first column's event number and second column is event time. But you can, of course, switch it up right here. Okay. Next, we're going into the third step, which is choosing your images. So this is all the photos that were taken. You're going to drag in, the simplest way is you can browse again, or you can drag and drop. So I have a folder here of all my images. Now, we're not actually uploading any of these images. You're just using the image file name as a way to correlate the event with the image. So I'll explain that in the last step. So just simply drag in all your files. It's going to sort them in the right order. And the last step, I think Nico mentioned this in the presentation, is this is your event file. These are the image names, and you're basically getting a list of what the photo ID would look like, which is an event number, time, and the correlated image. So the important thing you want to know is you actually won't even let you proceed to the final step until the active events, the number of events from your event file, match the number of images that you've uploaded. Now, if there's a misalignment or you want to remove a certain image, this is what this interface lets you do. So I can go in and let's say I don't want event 1 to be in there. I can remove event 1 and image 1, and my photo ID will start from event 2 and go onwards. So the goal here is allows you to actually exclude certain events, images, or both, so that they're not included in your final photo ID. But again, if these two numbers don't match, it won't let you proceed to the next step. So that's really important to make a note of. I'm going to hit generate photo ID, and that's it. I'm just going to go ahead and submit the project. Okay, project was uploaded successfully. And then under your account, you can go into your projects folder and you can see the status. So these are previous projects I've uploaded, how many SBET minutes or like flight minutes were included in that actual job after it was done processing. And the latest one I just submitted isn't currently in a processing state. So that's the process of getting the data up into our cloud environment. Once this is done, it takes a few minutes to process depending on the length of your mission. You will get a couple things. You will first get an email. As soon as it's ready, you'll get an email notification saying your project is ready and a direct link to download it. And you can download your projects at any time from here, from inside your account projects area. You can see all your previous projects and you can download them. So I'm going to show you the output of a file. This one's going to take a few minutes to process, but I've ran one a few minutes prior to the demo. And you simply hit the download button and we can go explore what the output is. So you get a zip file that when you unzip it, you get a series of files. The main file is the photo ID _ EO mission1.txt. This includes basically the information for the event ID, like the image ID, like the image name that we got from the file, and then all the information that's relevant, the time, the easting, northing, height, omega phi kappa, lat long, all the information you need. So this is the primary output that you would use to continue the next step of your processing. Other files are also included. We have a PDF. Mission 1 is called a report _ mission1.pdf. It kind of summarizes basically the performance, satellites, all that information about the processing, and a few other formats. But the primary kind of output of this system that you can use for your next step is the photo ID mission 1. And I think that's pretty much it. In a few minutes, you should be done processing. You'll get an email What a couple of things I want to touch on quickly before I hand it back to Nico for questions is Nico did mention when you reprocess an existing one, you'll get an icon like this that say, hey, we did not take away minutes because this is a reprocess mission. So reprocess missions are detected automatically. So if you upload the same project with different parameters, you won't get charged multiple times. And you'll see that in your project history. And I believe that's it. I'm going to hand it back to Nico and we can go to the Q&A.
Thank you very much, Henny. That sounds great. So I share my screen again here, just to go on with the slides. Yeah, that brings us to the Q&A session, as you said, Henny. So please use the Q&A icon at the bottom of this webinar and raise your questions there. And yeah, Henny, maybe you can go through the list and we'll try to answer your questions right now.
Okay, sounds great. We'll just go in order for now. There's about 7 or 8 questions. The first one is what maximum logging rates of GNSS observations are supported? Is it 1 Hertz, 10 Hertz, etc.?
I think we're pretty flexible on that. So I think at least it can go to 10 Hertz. It might even be more, but 10 Hertz is pretty much standard. But from my experience, even with 1 Hertz, you're supposed to get good data. Just make sure that when you provide the data, that the rover data, in case if you provide a base station, the rover data frequency equals the base station file frequencies. So if it's 10 Hertz on the rover, it should be 10 Hertz on the base to get 10 Hertz solution. On the other side, because you want to export, on the other side, because you create exterior orientation for your images, it will have to interpolate at the event time. So I think it's not so relevant to get a 10 Hertz solution out there. It's more relevant for you guys to get the position information at the image trigger moments or image trigger events, right? And that gets interpolated based on the photo ID file that is created on the web app, which is what Henny demonstrated. Okay.
Okay. Next question is, to get the best PPRTX solution, is it necessary to use triple frequency on the RhinoX, like L5, B3, E6, or is it okay using double frequency to get the best PPRTX?
Right. It's good to have the double frequencies, but especially for the global region, I think that's what I mentioned in the presentation. It would be ideal if you have those new Baidu 3 signals, and those signals are specifically called B1C and B2A. Those signals from the Baidu 3 generation, satellite generation, they're very precise and they're very helpful to improve the convergence time in the global region. In the fast region, we're very flexible anyways, because we have a good understanding of the GNSS errors. But in the global region, if you had those BD3 additional set signals, that's going to be very helpful. All right.
Okay, great. And the next question is, can the product, I'm assuming the question means, can a product output like binary SBIT and ASCII to be delivered at a higher rate than 1 Hertz, for example, 10 Hertz?
We can do that. Right now it's at 1 Hertz. If that's a requirement, we can change that. That's not a problem.
Okay.
Next one.
We have another question. I can kind of combine these 2 questions together. They're about the kind of data that you can process. So first part of the question is, can you process rover data collected with fixed wing or just drones? That's the first part. Second part is related to, can I process all data from equipment that Applanix PAWS and IMU collect?
Okay, so the first question is, we can process data from a fixed wing or a copter scenario, it doesn't matter. As long as the RhinoX file is kinematic, we are able to process. The second point is the combination of GNSS and inertial data, and that is not supported here. So this ApplanixPPK app is purely focusing on GNSS data processing. So it's doing GNSS differential processing. So only position data, no inertial data.
Okay.
Next one.
This one I think is actually kind of almost an extension of this one. This one's from Nancy. It says, how does the plan work for non-flights, like marine data, for example?
I think in general, everything works that comes with a kinematic Rhinex file. But as we said before, the entire thing is really tailored for UAV application, because when we speak about photo ID concept and that kind of stuff, it's typically something that comes from the camera drone payloads. So it's not specifically designed and tuned for any marine application, but in principle, it should work for kinematic Rhinex data in general.
Okay.
Okay, next one.
And this is also related to the input of the system. So for Rhinex input files, when converting from proprietary format to the Rhinex format prior to uploading, is there a specific converter that needs to be used, and what versions of Rhinex are supported as an input?
We support all of the Rhinex files. I'm not sure what the latest version is, 3.05 at least. That's up to that. We support it. That's not a problem. What was the other part of the question, Annie? Sorry.
Is there a specific converter program that needs to be used?
Okay. Well, yeah, there's typically, it really depends on what receiver is being used, and typically the supplier of the drones or the receiver, they are supposed to give you a converter, and in most cases, as far as I know, it's the RTK lib or RTK library that's being used to make the conversion from native formats into the Rhinex file. But that really sits with the user or with the supplier of the hardware equipment to the end user to provide a converter tool. So let's say there's no standard converter that I'm aware of, but I know that those suppliers, typically the hardware suppliers, they typically have something in place that allow you to convert to the kinematic Rhinex files. Okay, next.
Actually, that answers all the questions. So if you do have questions, feel free to drop them in. Actually, yeah, one just came in. Perfect timing. Actually, two just came in. Excellent. Okay. So, one is, can I process a T04 file?
I'm not sure we allow that, Henny.
No,
again, if the T04
Rhinex
file contains inertial data, definitely not.
I believe it sticks to a Rhinex file for this product, ApplanixPPK. We talked about the cloud solutions, the APIs. Of course, those are very flexible. Those are completely different products. Those are flexible. We can design, we can make them support any types of formats when you're in, like if you decide to go for mass scale production, and you can use, we had different licenses for different types of products, but this web application only supports Rhinex as an input.
Yeah, that's probably also a good addition to the other question that we have when it was asked about the GNSS and inertial data. So yeah, as Henny said, the Prospect Cloud API would fully support all of those constellations, while the ApplanixPPK is just really tuned and tailored for GNSS only processing.
Yeah.
All right, next one.
Yeah, awesome. So many questions coming in. This is great. Keep them coming. So next question is, can you clarify the concept of SBET minutes? Does it refer to the duration of the dynamic part of the GNSS logging? And what if the file only has static, like a static check on the ground?
Yeah, so in case of you sign up the subscription where we count for the flight minutes, these are going to be only the kinematic or dynamic data that are being logged. So we only deduct those. Any static data. So assuming your drone is on the ground for, let's say, 10 minutes and then it flies 5 minutes, we will only account for the 5 minutes. So we'll only charge 5 minutes and not the other 10 minutes on the ground. If you had only ground data, you will not be charged. But that's not the idea. The idea is not to process ground data, purely ground data. It's really what we want to achieve here is processing kinematic data. For instance, if you have a base station where you want to have the coordinate, then you use that extra function where it's also based on RTX, as I said before. So you can simply upload your base station and then say, please use RTX to survey in the base station coordinates, and it will do the job for that. But at the end, the idea is to merge the rover and the base, and you have some dynamic data. Okay. Hope that answers it. Next one.
Next one is it possible to change the datum of the PPRTX deliverable?
No, right now this is basically hard-coded to keep things easy. But yeah, if you see there's going to be a need in the market, then we can adopt it. Right now, when you go on the web app, it will tell you all the time what the output frame is. So that means when you use other photogrammetric software at the end or after the delivery of the georeferencing information, as long as you know what the datum is, other photogrammetric software should be able to do that transformation. But yeah, as we see the need in the market, we can adopt to that. We can give you the flexibility to output any frame that you want in the future. Right now, it is limited, and the web app does tell you what the frame is. Okay, next one.
Yeah, that's all we have right now.
All right.
Well, actually, sorry, one just came in. Okay, perfect. The output, someone's confirming, is the output WGS84 G1150 correct? Is that the output?
G what? Any second?
G1150.
1150. I think it's not the latest. The latest realization of the WGS84. I think there should be one later. Again, whenever you use PPRTX right now, or you use Smart Base, or you use Single Base Auto Download, what we supply is in the ITRF 2020 frame at the epoch of 2015. And the ITRF frame realization is equal to the latest WGS84, but it's of higher precision because this is an international reference frame, which is not only based on GPS observables, but also on other satellite navigation observables. And we output always in the latest international reference frame, which is the ITRF 2020. The only difference we do have is if you provide your own base station with your own coordinates, then the output will be in the same frame or same datum of your own base station, unless you survey it in with RTX. As soon as you use RTX or PPRTX, it will be ITRF 2020 at the epoch of 2015 right now. All right.
Okay. And
another one?
Yeah, it's a follow-up to this one. So thank you. And do you have a record of when the change was made?
To the change to the ITF 2020? Oh, yeah, we do have a record, but I think you can look it up on the French website. I don't have it in my mind, but I think we can take that offline. So that question can be addressed to me directly afterwards. I can give you the link and the information needed. I think it's 2 or 3 years ago when this ITF 2020 was published.
Okay, sounds great. Okay.
Any more questions?
No other questions at the moment.
Okay, perfect. I think that's good enough. If there's any other questions, no problem. We are available. So you can contact tech support at applanix.com anytime, or send me an email njäger@applanix.com. We'll try to answer your questions, no problem, anytime. In the web application itself, there's also a little widget that allows you to contact our support team if you have questions. So that should be straightforward. Okay, so we are at the end of this webinar. Thank you very much for your attendance. We really appreciated it. Let us know if there's any questions, any other questions, as I said. So take care and see you soon in one of our next webinars. Bye-bye then.